right, hello out there, folks. Today we're going to chat about a pretty cool topic, a little abstract, so you got to kind of buckle in on this one. It's talking about the changing path of the sun throughout the year, right? I mean, we all see the sun in the sky, you don't think much of it. But if you really pay attention, it totally changes its position, not only throughout the day, but throughout the year. You're really going to notice it when you start commuting to work someday, and sometimes of the year you're driving to work, you can't see a darn thing. Other times it's fine, and you're leaving at the same time. I mean, it's pretty wild how the sun's position changes throughout the year, and that's all because of, once again, the tilt, right? So the sun rises and sets, that's because of the Earth's rotation. But the changing seasons is caused by the tilt. Well, that's because the sun is at different angles and we receive different amounts of sun energy. So the changing position of the sun is also caused by the Earth's tilt. All right, pretty cool picture here. Up in Alaska, they call it the land of the midnight sun because in Alaska's summer, the sun never fully sets, right? It looks like it's about to set and then it goes back up. When you get above the Arctic Circle in the summertime, that Earth's North Pole is tilted toward the sun, so it always stays lit. Now, obviously, it gets a little darker here, right, towards like a dusk, but it comes right back up. Land of the midnight sun. All right, I have some video footage of this. Pretty wild stuff. Check this out. This camera follows the sun as it goes around the sky. It tracks it, and of course, it tracks it at that rate of the Earth's rotation, 15 degrees per hour. Check this out. It's about to set, but nope.
April in the Arctic, and already the sun has set. But further south, the sun works.
There's solar noon, and down it comes.
Familiar ways.
And as the lowest point would be midnight, and that's midnight, and back up it comes. 6, 7, 8, 9, 10, 11. That's about 12 solar noon right at the highest point. And here we go, 1 p.m., 2 p.m., 3 p.m., 4 p.m., until it gets to its lowest point. Of course, that would be midnight once again. And it does this for 6 months, this awesome cycle there. All right, land of the midnight sun, there it is. All right, so make sure you read this blurb here. It tells you about the sun's motion of 15 degrees per hour. Of course, that's because of the Earth's rotational speed. And it goes through some other interesting information. Here's just a rough drawing of the paths of the sun throughout the year. We're going to get more specific in a minute. But winter, obviously, the lowest path, right? Receiving the least direct sunlight. And summer, the highest path, receiving the most direct. Okay, this is called the celestial sphere. And what you got to kind of do with these, you got to picture you as this guy right here. So you're in the middle of this sphere. You got to picture this dome over your head, like a giant salad bowl over your head. All right? For most of these scenarios, we're going to be facing a particular direction. In this case, we're going to be facing south because in Elmont, the noon sun is always going to be in the south. So we're going to situate ourselves facing this way. All right, there's good old Polaris, and that's our latitude, Elmont at 40 degrees north. Now, I've left some of the things in the diagrams for you, so you're not scrambling around trying to draw it all in. But certainly, of course, you got to try to work with me and fill in the blanks here. All right, label your Polaris 40 degrees. The highest point in the sky is called the zenith. That's the point directly over your head. My zenith is different than yours, right? We're in two different places, and we each can look up 90 degrees directly over our head, and that would be the zenith. All right, the horizon is always where the sky meets the ground. That's 0 degrees. All right. And here we go. We're starting out over here. This is going to be sunrise on an equinox day. Could be March or September 21st or 23rd there. Spring or fall. Either way, on the equinox day, it's always going to rise due east on an equinox day. All right? It's also going to set due west. That's your sunset on an equinox day. Those are the only 2 days where the sun actually rises directly east and sets directly west. Everybody has in their head, oh, the sun rises in the east. Well, generally speaking, yes, but it only rises directly east on equinox days. Every other day of the year, it's either rising slightly south of east or slightly north of east. Okay? So there you have it. This is going to be our solar noon sun. Okay, and that measurement is about 50 degrees in Elmont. Okay, and that's 50 degrees above the horizon. So you're going to sketch the path of the sun. You're going to start at the sunrise, you're going to go to the solar noon, and then you're going to go down to the west, the sunset. Now notice we go solid in the front, dash in the back, kind of gives you a 3D feel there, okay? And that is the arc of the sun, the path of the sun on an equinox day in Elmont, okay? Now we're going to go towards wintertime, which of course is what we're in now. So notice the sunrise is now south of east, right? This would be the winter solstice. We passed that not long ago. And I wonder if you can figure out where the sun would set. If it rises south of east, well, it would set south of west. And of course, it's going to be much lower, right? The solar noon sun is going to be much, much lower. In fact, it's going to be 23.5 degrees lower, right? The tilt of the earth. So you would do 50 minus 23.5 and you would get 26.5. Okay, now connect these two up. Go solid in the front, dash in the back, and you have the path of the sun in the wintertime. If you have to hit pause, that's totally cool. Notice how much lower the arc is, how much shorter it is. That's why the days are shorter. The sun is lower, so you're going to get more reflecting off the ground, right? That's why we get colder, less direct sunlight. Let's go the opposite way. Let's go towards summer. Everybody wants it to get warmer. Well, how does that happen? Well, the sun has to move its position, right? All this is happening, once again, because of the Earth's tilt as we revolve around the sun. So here we go. Sunrise in the summertime is going to be way north of east. Look at the difference there. So label that as your June 21st summer solstice. And it's going to set way north of west, right? So label that one your sunset on the summer solstice. And look at the height difference between winter and equinox. Well, it's going to be the same height difference between equinox and summer. So you would take 50 and add the tilt of the earth, right? Add that 23.5 degrees for a whopping 73.5 degrees. All right, folks, use your best artistic skills. Connect sunrise with a nice smooth arc up and sunset with a nice smooth arc down. Look at the size of that path. Absolutely enormous. That's why we get 15-hour days in Elmont in the summer compared to a lonely 9-hour days of daylight in the winter. All right. Look at how much higher the sun is. That's why we're at greater risk of getting sunburns in the summer. Much more intense insolation. We get way hotter. And there's that difference, right? That Earth's tilt of a difference between the seasons there. All right. So take a screenshot of that if you need to, but I think you'll probably follow along at this point. All right. The sun is always seen in the south in Elmont, right? We're in the northern hemisphere, so we have to look south to see the noon sun, I should say. And that's why they say moss will grow on the north side of a tree, because that direct sunlight, right, hits the south side. It's too hot for the moss to grow, but the north side is going to be the side of your house where the siding will have like little green algae or moss growing on it because it's a lot cooler and the plants can thrive there. Okay. Notice the sun is never directly overhead at the zenith in Elmont, right? If you want that, you got to go into the tropics. But Elmont, we're too far north for that. All right, let's change locations. Speaking of the tropics, let's go to the equator. And there's Polaris now. Notice the altitude of Polaris equals your latitude, right? The latitude is 0, so Polaris is 0. And here we go. Sun's going to rise due east, right? We're on an equinox day. And it's going to set due west, again, on an equinox day. That's the same no matter where you are. But the rest of the arc's going to look different. Okay? Look at this. On an equinox day at the equator, the sun will be at the zenith at noon. So up it goes, down it goes, right? This crazy high path. On the equator, the days are always about 12 hours, and you can see it'll take up about half of that arc, right? The rest of the arc is nighttime. We're going to move over to winter, right? There is no real winter on the equator. But here's December 21st, and notice this difference here. Just like in Elmont, but now, look, it still goes high. So even though it's December 21st, it's still going to be warm on the equator because they still get that crazy, crazy high altitude sun. Same thing for their summer months. You just scoot it over to the other side, and it goes again straight up for another hot day. So all year round at the equator, it's hot because they're always getting direct sunlight. The days are always about 12 hours, but you don't get that tilting effect because you're directly on the equator. Okay? All right. Last one I'll show you. Well, not the second to last one. In the southern hemisphere, things are opposite. I'm going to go a little faster through this one. They don't have a Polaris. They have what's called a Southern Cross. So that's about 40 degrees above the horizon. So that's 40 degrees, but now we're in the southern hemisphere, mind you. And look what happens with the path that the sun goes. It swings the other way, right? Things are always opposite in the southern hemisphere. And the sun's path is no different. Okay? Same thing with their winter sun. It's going to be lower, shorter path, but it's, again, swinging to the north instead of the south like Elmont. Okay? And their summer path, you probably figured it's that same pattern. Okay? Notice it doesn't hit the zenith, right? You're not in the tropics. You're at 40 degrees. The tropics are between 23.5 north and 23.5 south. Last one I want to show you is at the North Pole here. Check this out. So the zenith is still overhead, and so is Polaris, because the altitude of Polaris equals your latitude. Well, 90 degrees up is the zenith. Check it out. So let's say we're in the summer at the North Pole. Look at the arc of the sun. It never sets. Like that video in the beginning, it never sets. It just keeps going around. On an equinox day, it rises right above the horizon, goes round, 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 gets higher and higher. This would be June 21st, and then it would be July, August, September, and then October, November, December, January, February, March, you wouldn't see it all. It would all be below the horizon. So they get 6 months of light and 6 months of dark. Okay, talk about an extreme climate, right? All right, that's what it would look like at the North Pole. You can see here the Arctic Circle totally illuminated, right? That's what's going on here. The sun never sets, never goes into the shadow. That's that 24-hour day. Okay? There's your equinox path on the North Pole, and you can see the North Pole cut directly in half with that shadow effect. Okay. So you got a couple questions to crank on. Obviously, we will go through this together, but you got to put some love into this one, folks. I'll meet you back in the meet.